So today we're going to be doing Physics 1, Lab 1 for charge shapes. My name is Andrew Arthur. Let's get started. So some basic equations you have to know are Coulomb's law and the gravitational force. Coulomb's law being describing the force between two charged particles, Q1 and Q2. Gravitational force describing the force of gravity on a particle. We can assume there are two charges in this experiment are going to be equal, and you can get and that because of this they will repel each other. And thus we can say that instead of Q1 times Q2, it's just going to be Q squared. Now, the actual mechanics of the lab will basically include taking a piece of tape and ripping it off of another piece of tape, causing that tape to get charged. This is due to the other piece of tape basically either losing or gaining electrons from the base tape. And based on this, we can now observe how this charged tape will interact with other objects, including another charged tape, my hand, my notebook, and also a negatively charged pen. To all of these things, the two neutral objects should be attracted to the tape, and that the tapes should be repelled by each other. Basically, because we repeated the exact same procedure for both tapes, that means that in essence they should have the same charge, so they should also be the same charge. They should be both positive or both negative. With the tape in my hand, with the notebook in my hand, I meant that these should both be attracted to the tape, or the tape should be attracted to them, due to the concept of dipoles and how the presence of an electric field should induce a dipole within my hand and the notebook, thus causing the tape to be attracted to them. Now, then, to observe the interaction between the two tapes, I'm basically taking one tape, putting it on top of a stacked piece of pile of books, and taking another tape and moving it below that first tape. The upper tape we will call tape B. The lower tape will be called tape A. Tape B is our system. Every force in this experiment is calculated in relation to tape B, a force acting upon tape B. Whereas tape A, the books, my hands, the rest of the universe, is what's called the surroundings. I also record some other values here, which you can look over if you like. The most notable ones would be the charge of an electron, being negative 1.6 times 10 to the negative 19th coulombs, associated with gravity, and the area of an atom, that being 1 angstrom squared, which is a little bit of approximation for the sake of the lab. Now our observations. The neutral objects were attracted to the tapes. Great. The charged shapes will repel each other. And we took a negatively charged pen, brought it close to tapes, and it was attracted. Like charges attract each other, like charges repel each other, the opposite charges attract each other. Because the negatively charged pen was attracted to the perfect tapes, thus the tapes, we can now officially say, are both negatively charged. Now, we will briefly go over some results here. The distance between tape A and tape B was 0.024 meters, and that the force of gravity acting upon tape B should be negative 1.91 times 10 to the negative third newtons. But we can set the force of gravity equal to the electric force because the tape is floating. That means that the electric force has to counterbalance the force of gravity, so they should be equal to each other. There might be other forces at play here, but we should really just assume for the sake of simplicity that these are the only two forces here. Now from the electric force, you can get the charge of the tape, that being 1.106 times 10 to the negative 8th coulombs, and then you take that charge divided by the charge of absolute value of the charge of an electron to get the number of deficient electrons, being 6.915 times 10 to the 10th number of electrons. We can take the area of the tape, divide that by the area of an atom, and then we get the number of atoms on the tape surface. And then we can take this area of atoms on the tape surface, 3.705 times 10 to the 17th atoms, divide that, and then we can have the number of deficient electrons divided by this number to get the ratio of deficient electrons to atoms to be 1.866 times 10 to the negative 7th. There isn't units here. Sorry about that one. Now, for the computational model, it's eventually just modeling exactly what we explored here. When we said we're going to have the green arrow as representative of the electrostatic force, the red arrow is representative of the force of gravity, our blue particle is going to be our tape B, the red particle is tape A. And essentially, like I said, because tape B is our system, all the forces are done with relation to tape B. We also have here that prints out some values here. Now these values might be a little different from the values that we calculate through an experiment, and this is because of the assumptions that we made. We assume that the charges on the tape are localized to a single point charge in the center of the tape. Charges of tape A and B are equal, and the charges of the tape are uniform, and there are no disruptions in the electric field. All of these might not actually be true necessarily, and this leads us to some sources of error. Even while doing the experiment, we assume that the charge is uniform across both tapes. Might not be true. These tapes might be slightly different lengths. they're going to be slightly different in many ways. Then there also means the interference of electric field by outside objects, like a neutral hand, by like my hand. Basically, if a neutral object comes in contact with a charged object, that means that it might gain back some electrons. That's why it's important to handle these other charge shapes as little as possible. And finally, there's going to be disparity of charges between tape A and B. Now, if the electrons have positive charge and the protons have negative charge, literally nothing would change. Everything would be the exact same. What particles are positive and negative is completely arbitrary. Thank you for listening to this. Have a wonderful day.